Thank you, everyone, for coming to my talk this afternoon. I'm Michael. I'm a co-founder and CEO of Brevis. And at Brevis, what we're building is what we call the infinite compute layer for Web3. And it's a smart, verifiable computing platform that allows you to offload very complex and heavy data computation from blockchain to an off-chain environment where you can essentially generate a ZK proof and verify it on-chain. But before I dive into what exactly Brevis does, let me kind of try to describe the problem we're trying to solve a little bit more. And that's not the right clicker. Okay, so blockchains are often advertised as world computers, but if you think about it, they're actually some crappy world computers themselves, because none of them can run faster than a single server, and they're generally very, very expensive to run. Now, what is the fundamental reason for that? Well, you may say that wait a minute. We have done so much in the last 10 years in blockchain scaling. We should be able to just run any kind of a computation on blockchain, especially layer 1 blockchains today. Well, unfortunately, that is not the case. Let me give you a very, very simple example here. That is why we don't even have VIP trader programs on DEXs. VIP trader programs, you see them on all your centralized exchanges. The concept is very simple. If you trade a lot, you become a VIP of the exchange, and then you get a trading fee discount. But the reason they don't have this in your smart contract-based DEXs is because building this in smart contract and running this kind of computation to calculate what is the user's historical trading volume turns out to be extremely expensive. So, that's kind of like the scalability constraint you're still facing in today's modern blockchains, especially layer 1 blockchains. But even if you're doing this on the cheapest layer 2 that is available, you're still faced with a huge amount of transaction fee that is going to bankrupt the entire chain. So the fundamental reason behind this is that today's layer 1 and blockchain consensus are built on a very, very simple form of computation. So let's say, here we're trying to achieve a consensus between two nodes, Alice and Bob. Alice is doing this computation and trying to convince Bob the same. So what we do here in the simplest form of computing is that Alice will do the computation herself, and then, tells Bob, hey, this is the result of the computation. Now, how does Bob know the result is actually correct? Oh, what's going on? Okay, so how can Bob know this result is actually correct? Well, the simplest thing Bob can do is to do the computation again. So, Bob spends the same amount of computation power and do the same kind of computation. And we use recomputation as a way to do verification and the only way to achieve consensus in today's consensus protocols. So what this means is that let's say you're trying to process this kind of a swap in your DEXs with one single node. But if you're trying to do this on Ethereum, for example, there are like 800,000 or close to 1 million nodes. What's going to happen eventually is that you're going to repeat the same piece of computation again for 1 million times. Now, this is the fundamental reason why blockchains and layer 1 blockchains are expensive today. So how do we solve that? Well, we can solve this fundamental challenge with something called verifiable computing. So in verifiable computing, you have different roles in the entire computation process. You have something called a prover, in which case it's Alice. So for Alice, she's not only doing the computation itself, but also generates something called a zero knowledge proof. Now, this zero knowledge proof is a very magical thing that she can send it to Bob. And for Bob, he doesn't actually need to do the computation again, but instead just verify the proof with extremely low cost and extremely low latency. Now, the magical thing about ZK proof is that you can decouple the process of doing the computation with the verification of the computation itself. And also, very importantly, with ZK proof, it doesn't actually matter what is the complexity of the original computation. Once you generate the proof, the cost of verification mostly stays constant. So this is like a very, very powerful paradigm that you can use to build faster, blockchains and many other things. So, Brevis is actually used in many different kind of scenarios, but in blockchain specifically, what you can do is instead of putting all the heavy and data complex computation on chain, you can move them away from blockchain to an off-chain environment. And in that off-chain environment, what we can do is you can generate a ZK proof and send the proof back to the blockchain, where the blockchain itself can only just verify the proof in the smart contract with extremely low cost and low latency, and become only the glue point of very complex computation. And with this kind of new paradigm, you essentially extend the capability of blockchain computation to infinity, because whenever you encounter something that is too complex to do on-chain, you can just offload it to this kind of verifiable off-chain environment. So I want to highlight that this kind of computation is not theoretical anymore. So this is actually being used by numerous different kind of applications, and in various different kind of sectors. Like MetaMask, PancakeSwap, Uniswap, Beefy, OpenEther, Euro, Linea, and all these different kind of top tier applications that actually use the Brevis today to power a new generation of features that is available in their application. So some very quick examples. Well, we talked about this, and you can essentially just have the capability to now, on PancakeSwap, use the Brevis to generate a proof that you have actually traded a lot on the exchange, and then kind of get a transaction fee and trading discount. And we're actually building something even more exciting in the intelligent DeFi space to essentially allow you to build a new generation of perpetual swap exchanges that have the same experience of a centralized exchange, but at the same time gives you the same kind of security of layer 1, because you settle all these kind of matching process using ZK to the layer 1 blockchain, but at the same time, you can also get some additional privacy benefit because you can enable something like a dark pool order. And speaking of privacy, and especially for this event, we are enabling a variety of privacy preserving verification features for many different applications, including Kaito. So on Kaito today, user can essentially generate attestation of their wallet token holding amount without actually revealing the amount of tokens they hold and revealing the exact wallet address, and associated that attestation with their social profile to say that, okay, look, I'm giving some opinion about like DeFi market. And I can prove that I'm a power user for DeFi, but I don't need to show you what exactly is my wallet address. And this is a kind of a feature that can be achieved by Brevis as well. And we are also kind of doing a lot of things in the RWA and the stable token space to allow kind of a distribution and launch of stable token and real-world asset ecosystem. So once you launch a stable token, the next thing you need to do is to actually get them embedded in the entire DeFi ecosystem. Well, how do you do that? You need to design a reward program that can organically embed your stable token into all these kind of DeFi protocols and allow users to kind of actually use them. Well, how do you do that? You need a system that is actually trustless and secure and transparent, so that the user knows that, okay, I'm getting this reward not because I'm a good friend with this project, but also because because I'm actually a power user for the protocol itself. So now, with Brevis, what we can do is that we build something called continuous protocol incentivization to allow users to generate ZK proof of their interaction with the different protocols using the stable token, and use that as a way to get user protocol reward. And similarly, we recently launched with the Linea for their Linea Ignition program to help distribute a 1 billion Linea token using ZK proof as well. So there are many different kind of applications we're running, but my prediction here is that as you can see, verifiable computing is actually being adopted by all these kind of different top tier projects, and in 10 years, I would say 99% of all computation for blockchain applications are gonna happen off-chain, and hopefully verified by ZK proof and Brevis. So, okay, so I've been talking about Brevis, but what is actually inside this magic box? So the entire Brevis stack consists of 3 parts. In the middle, it's something called a Pickle ZK VM. And then, we have some co-processors and the prover network that support this whole thing. So Pico is a RISC-V based ZK VM that you can use to prove really any kind of software computation. It's a RISC-V ISA VM with the function level precompiles. So, because it is a high-level and general-purpose ZK VM, the developer experience is very drastically different from your traditional zero-knowledge proof development experience. You can basically write high-level programming languages without actually relying on low-level understanding of the zero-knowledge proof protocols. So, for example, this is like the kind of a program you run if you want to essentially prove the correct computation of Fibonacci numbers. And what this means is that once you have this, you can essentially run your entire Ethereum client like in Rust in a verifiable way. So with this, you totally change how Ethereum layer 1 consensus work, because now instead of having all 800,000 nodes repeat the same kind of computation, you only need to have one node does the computation itself and generate the proof, so the entire rest of the network can just verify the proof with extremely low cost. And this is what we're doing, and this is how we're helping to change the Ethereum layer 1 scaling landscape by essentially proving Ethereum blocks in real time in terms of execution. Now, what this means is that you can essentially have a Pico to essentially generate a ZK proof, and the rest of the network can just verify the proof, and the entire processing cost fundamentally will decrease by orders of magnitude. And we currently provide the fastest ZK VM for Ethereum proving, in production. And you can, what happened? You can refer to our, you can refer to ETH proofs, which is like a layer 2 bits equivalent for ZK VMs for more detail about the performance of our Pico ZK VM. And Pico is very performant, but the performance is not enough. And in fact, we know that because Pico is like a very generalized ZK VM, it definitely makes some trade-offs in terms of the performance and generality. So, the performance of Pico is not going to be as fast as a specialized circuit, but for Brevis, we want it to operate at the optimal point of the trade-off plane. So how do we do that? Well, this is actually thanks to, this is like the modularity here is to the rescue, where we build Pico in a very modular way, where we have a very general glue in the middle, and then you can add a bunch of plug-in into this entire system to make specialized use cases and specific use cases much faster to run. So, instead of just relying on the general VM, we have a bunch of application-level coprocessors. Some of them focus on on-chain data coprocessing, some of them focusing on ZKML and others. So specifically, we have an on-chain ZK data coprocessing, ZK coprocessor that allows you to generate ZK proof for any historical on-chain data and run arbitrary computation on top of them. And this gives you another 2 orders of magnitude faster performance for these kind of use cases that when you need actually on-chain data processing. And this is precisely why with the Brevis, you can actually build a lot of different kind of use cases that is production ready, because we have this kind of a very unique modular and glue and coprocessor architecture that is embedded in our entire architecture. So finally, what we have here is that you have a very general ZK VM and then a bunch of coprocessors. What we also have is something called a Brevis prover net that allows you to generate proof in a transparent and a decentralized way. And it really helps you to handle heterogeneous workload with a new kind of auction mechanism called truthful online double auction that allows you to actually cater to different and a very kind of a diverse set of workload that is possible and needed in the entire proving process. And we're launching the prover network very soon. And hope you guys can follow us here. And if you have any questions, you can always find us after the talk. Thank you.